Good morning, algebra students. So this is your practice problems and video for the week. So if you guys are working through your problems this week, and if you have any questions, let me know and we can jump on Zoom and I can help you. So let's look at this first problem. It says, which of these polynomials is a fifth degree binomial? So remember, it's considered the number that has the largest exponent. That's what they're talking about by a degree, right? So letter A, the largest exponent is a 5. So this is a fifth degree polynomial. The second one, the largest exponent is 3. So this is a third degree polynomial. Letter C, this largest exponent is a 5. So this is a fifth degree polynomial. And then the last one is a third degree polynomial. Now, the way we get this term, of course, is by how many terms there are. So this is a third degree binomial because there's 2 of them. The first one is a fifth degree, but it has 3 terms. So it's not a binomial. It has 3 terms, so they just classify it as a polynomial. However, letter C does have exactly 2 terms, which makes it a binomial, and it has an exponent of 5. That's the greatest exponent, and so it is a fifth degree binomial. So I know last week you guys did classify it polynomials. I just wanted to remind you of how to do that. All right, so we're going to start multiplying binomials times binomials and binomials times trinomials. So here we have a monomial, 1 term, times a trinomial, 3 terms. So we're just using a distributive property. And then you got to remember those exponent rules, okay? So 3x, so there's 1x is raised to the first power. So 3x times x to the third, since it's a multiplication problem, we're going to add those exponents. And there's the coefficient of this number right here is a 1. So 3 times 1 is 3. And then when we add those 2 exponents together, we get x to the 4th. Excuse me. 3 times negative 2 is minus 6. And then 1 plus 2 is x to the 3rd. And then finally, 3 times 4 is 12. And we bring our x over. And that is our answer. Now, we cannot add those coefficients because they're unlike terms, because they all have different, the variables all have different exponents. So that's the final answer. All right, so now we're going to multiply 2 binomials. Now, they use this term called the FOIL method. And some people it helps and other people just don't really need it. But basically what the FOIL method, what it means is first you do the first 2 terms, you multiply the first 2 terms. The O means the outside terms. The I stands for inside terms. And L means the last 2 terms. So that's why they call it FOIL. So the first 2 terms is you multiply 5x times negative 2x, and we get negative 10x. And then the outside terms is 5x times 8. Well, 5x times 8 is positive 40x. The inside terms is 3 times negative 2x. So 3 times negative 2x is negative 6x. And then the last 2 terms would be 3 times 8, which is positive 24. After you multiply all those terms together, you're going to combine like terms. So look what I did. It's 10x squared. I'm so sorry. 5x times negative 2x is negative 10x squared. My bad. So, but do you notice these 2 middle terms are like terms? So we bring down our negative 10x squared. 40x minus 6x is positive 34x. And then 24 is, it doesn't have any like terms. So that is our final answer. All right, let's try letter B. So we're going to FOIL this. So we're going to do first 2 terms. 4x times 3x is 12x squared. And then our outside terms is 4x times negative 2y. So 4 times negative 2 is negative 8. And then x times y is xy. And then we're going to multiply these two inside terms. So 3 times 3 is positive 9. And x times y is x times y is xy. And then finally, the last two terms, 3y times negative 2y is minus 6y squared. Once again, our two middle terms are like terms. So negative 8xy plus 9xy is positive 1xy. So we bring down our 12x squared plus 1xy. We don't need the 1. And then minus 6y squared. We've combined our like terms, and so this is our final answer. And that's what they call the FOIL method, which is just using the distributive property, same thing. All right, now a binomial times a trinomial. So we're going to multiply each term by 5x, and then we got to multiply every single term by 3, okay? So 5x times negative 3x squared, so 5 times 3 is negative 15, and x times x squared is x to the third. Then 5x times 2x is positive 10x squared. And then 5x times negative 10 is minus 50x. Now we're going to move on to our 3. 3 times negative 3x squared is negative 9x squared. 3 times 2x is 6x. And 3 times negative 10 is negative 30. Now we got to combine all of our like terms. Well, this one that has the biggest exponent doesn't have any like terms. So part of our answer is negative 15x to the third. Then we're going to add 10x squared minus 9x squared. 10 minus 9 is positive 1x squared. Now we have negative 50 combined with positive 6, negative 50x combined with positive 6x is negative 44x. And then finally, our constant 30 stands alone. All right, you guys do good on that one? I bet you did. All right, moving on. Oh, I wrote all over that. Let's get rid of this. So find the area of this rectangle. So of course you find area of rectangles by multiplying the base times the height. So we're going to multiply length or width, whatever you want to call it. Our length or our width is x plus 5, and our other dimension is 2x minus 4. So we're going to multiply these two together. So we're going to use our FOIL method. So x times 2x is 2x squared. X times negative 4 is minus 4x. 5 times 2x is positive 10x. And then 5 times negative 4 is minus 20. Those two middle terms are like terms. So what is the final answer? Is 2x squared plus 6x minus 20. So that is the area of that rectangle. All right, number 6. Now this says, we don't have a picture, but it tells us the following table shows the length and width of two rectangles. Which expression is the result of the perimeter of rectangle B minus the perimeter of rectangle A? So to find the perimeter, we would add up all 4 sides, right? So they give us that this is 3x plus 2, and this is 2x minus 1. But since we're doing perimeter, we have to double these two dimensions and add them together, right? So then we're going to do rectangle B is x plus 5. We'll do the longest one, 5x minus 1 and x plus 5. All right, so we're going to double these. because there's 2 widths and 2 lengths to both of them, to everything, right? So let's do that first. All right, so 2 times 2x, let's do it down here. 2 times 2x is 4x, and 2 times -1 is -2. And that is the top and bottom added together, plus 2 times 3x is 6x, and then 2 times 2 is 4. And now we're going to combine like terms. So 4x plus 6x is 10x, and -2 plus 4 is +2. So this is A, right? This is rectangle A. So then we're going to double these over here for B. Let me change colors. All right, so 2 times 5x is 10x. 2 times -1 is -2. 2 times x is 2x, and then 5 times 2 is +10. So when we combine our like terms, we get 10x plus 2x is 12x, and then -2 plus 10 is 8. So what does it say? We're going to take the perimeter of triangle B, which is 12x plus 8, and we're subtracting this perimeter, right? So from it, we're subtracting 10x plus 2. Now remember, when you have a negative sign in front of a parentheses, you have to distribute that negative sign to everything in the parentheses. So we're going to write this 12x plus 8. So minus 10x, but not just minus 10x, minus 2. So finally, we combine like terms. 12x minus 10x is 2x, and 8 minus 2 is +6. So that is how you do that problem, and you will have that problem this week. All right, does that make sense, guys? Okay, coffee break, everyone. Yum. All right, we are moving on. So there's this thing called the closure property. It says if A and B are real numbers, then A plus B is a unique real number. For example, 2 plus 3, real numbers equals 5, which is a real number. If A and B are real numbers, then A times B is a real number. So 5 and 2, real numbers, you multiply them together, you get 10, a real number, okay? Now, when you're talking about polynomials, it says if you add a polynomial to another polynomial, you'll get a polynomial. That makes sense. So 2x plus, if we combine our like terms, 2x plus 5x. So first of all, this doesn't have a like term. 2x plus 5x is 7x, and then -3 is standing alone. So if you add a polynomial to a polynomial, you'll get this is a polynomial. So that makes sense, right? Then it says if you multiply a polynomial to another polynomial, you'll get a polynomial. So we would use our FOIL method. 2x times x squared would be 2x to the third. 2x times 5x is 10x squared. -3 times 2x is -3x squared. And then -3 times 5x is -15x. Those two middle terms are like terms. So we get 2x to the third plus 7x squared minus 15x. And that is a polynomial. So that is true. However, when you divide two polynomials, you do not always get a polynomial. So here we have 5x minus 2, which is a polynomial, divided by x, which is a polynomial. And your answer is this right here. And when we go back and look at polynomials, we're not allowed to have a variable in the denominator in a polynomial. So the closure property is true for all of these statements up here. However, division is not included in the closure property. All right. Now, for some reason, this curriculum wants you to understand that. So to prove that let's just look at a problem. Okay. Let's just go look at a problem. So this is the example I'm talking about. Which statement shows how two polynomials demonstrate the closure property when multiplied? All right, so I want you guys to write down this problem. I want you to use the FOIL method or just distributed property. And I want you guys to pause the video, figure out the answer, and then come back. All right, so what'd you guys get? I got 8x to the third minus 32x plus 12x squared. Uh-oh, I forgot that. And then minus 48x. Did y'all get that? And then those two middle terms will simplify, or they will, yeah, simplify, I guess. We get negative 20x squared minus 48. Did I do that right? I think I did. All right, so which of these statements proves that this polynomial times this polynomial demonstrates the closure property? Well, it's this one. I think I got that answer right. Did I get it right? You guys did it right. Yeah. So you just come up with the right answer and you state that this is a polynomial, which it is. So that's the closure property type problem that you will see this week. All right, now there are binomials times binomials, which are considered special products. And the reason they're considered special products is because, oh, this is supposed to be a minus. I need to change that. The reason they're called special products is because there's always a pattern in the answers, okay? So let's look at this one. So basically it's telling us to take this binomial and square it, which means we're gonna multiply it by itself. Whoops, did I write it wrong? I did write it wrong. All right, so let's do 3x times 3x. You guys do it on your own and then check your answer. And then we have 6xy, 6xy, and then 4y squared. When you combine your two middle terms, you get 9x squared plus 12x squared, no, 12xy plus 4y squared, okay? Now, number 9, hopefully I'll remember to change this before I send this to you. So that's what you get when you add a binomial squared. So what if we have 3x minus 2y squared? Well, if you multiply everything together, 6xy minus 6xy plus 4y squared. So we're going to get 9x squared minus 12xy plus 4y squared. And see how similar these two are? The only difference is that minus sign right here. Okay, so basically what happens is when you have a binomial squared, you're going to take that first number and you're going to square it, and that's going to be the first term. So 3x squared is 9x, right? The very, very last term is by squaring this. 2y times 2y is 4y squared. So that's going to always match. And then to get the middle term is if you multiply these together, 3x times 2y is 6y squared. If you double it, you're always going to get that middle term. So isn't this 6xy doubled is 12xy? Oh, yeah. All right, and the same pattern goes for the second one. The only single difference is that minus sign. Now, do I expect you, or does any math teacher expect you to memorize this? Not really. Because after you FOIL it, you're going to get that pattern anyway. So if you recognize it on site because you remember this pattern over here, that's great. But if not, FOIL it, get the right answer, and no one's going to know the difference. Okay, just between me and you. All right, now these two are kind of handy when you've done math for a while. You recognize when you have a difference of squares. So on the previous page, you take the same binomial and you square it. So if the first one's plus, the second binomial is going to be plus. Now these, however, if one is a plus and one's a minus, then it's easy to find the pattern of this situation. So let me do it longhand first. So if we use our FOIL method, we're going to do x squared minus 5x plus 5x minus 25. Now, every single time, if you have a plus and a minus and everything else matches, those middle two terms are going to cancel each other out every time. And all you have is basically the first number squared, the second term squared, and a minus between them. Because 5 times negative 5 is going to be always negative 25. Okay? And that's going to be a pattern every time. But like I said, if you don't remember that and you FOIL it and then you combine like terms, you're going to get the same answer anyway. So here we have everything matches exactly, and we have 1 plus and 1 minus, right? So we should take the first number, square it. And then the two middle terms will cancel. So then you take the last terms, you square it, and you get minus whatever that is, okay? So let's do it longhand to make sure we get the right answer. So 3 times 3, 3x times 3x is 9x squared. 3x times 4x is positive 12xy. I know I said x, but I meant y. And then the middle terms would be negative 4y times 3x would be negative 12xy. So what do these two terms do? They cancel each other. And then finally, negative 4y times positive 4y is negative 16y squared. So when we combine like terms, these cancel, and this is what we get. Okay? So, and those are just called special products because the pattern repeats every time. And this is that pattern basically. Same numbers in both sets of parentheses, one with a plus, one with a minus. You're going to get this answer every time. You square the first one, you square the second one, and you put a minus between them. So that might save you some time if you choose to, if you recognize that it's the difference of two squares. That's what it's called. All right, you guys. Well, that's it for this week. I hope you guys have a wonderful week, and let me know if you need me, and I will be happy to help you in any way I can. Have a good day.